electromagnetic acoustic imaging. Let's start. Medical imaging technology in today's societies lasted for a few decades, based on the experience and the development of X-ray, B ultrasound, CT scans, and MRI. But it was observed that the radiation used in body scanning imaging field is expensive and cannot be miniaturized, and it's difficult to move the devices from one place to another due to their large size. Other disadvantages of old medical imaging technology, such as nuclear magnetic resonance imaging system, is the high cost, the presence of ionizing radiation, and claustrophobic, which can cause side effects to body tissues. Moreover, CT scan also has ionizing radiation, and the resolution of ultra-wideband electromagnetic imaging is quite low. Additionally, noise of ultrasonic image is relatively large. The field of medical electronics technology in the University of Oxford has gained an excellent reputation internationally. Electromagnetic acoustic imaging, developed at the University of Oxford, is based on the existing technology. A new system was invented using both electromagnetic and acoustic principles of the new commercial equipment and technology. The resolution of its images is quite good. That can be compared to the imaging resolution of nuclear magnetic resonance, but without the use of radioactive material, and the cost will be reduced to the level of B ultrasound cost. How does electromagnetic acoustic imaging work? It's a new imaging technique that uses long wavelength of radio frequency to induce ultrasound emission. Signal intensity and image contrast have been found to depend on spatially varying electrical conductivity of the medium, in addition to conventional acoustic properties. The resultant conductivity-weighted ultrasound data may enhance the diagnostic performance of medical ultrasound in cancer and cardiovascular applications because of the known changes in conductivity of malignancy and blood-filled spaces. Before applying this device in humans, this is a section through a sheep's kidney. On the left-hand side, we can see the red ring, which indicates calcium carbonate nodule has been inserted as a proxy for a kidney stone or vascularized tumor. The same section with a registered ultrasound emission superposed. The nodule can be seen, but it's not differentiated from other features in the kidney. Whereas the ultrasound and electromagnetic acoustic imaging scan superpose the different electrical properties of the anomaly stand out extremely clearly in the electromagnetic acoustic imaging scan as a brightly colored area of relatively high permittivity and conductivity. The advantages of electromagnetic acoustic imaging. 1. It provides clear and high quality image with high resolution and contrast. 2. It can give same results as MRI but with equipment as cheap as ultrasound imaging. 3. The hardware complexity and scanning time. 4. Improves the efficiency and patient imaging comfort. 5. No ionizing radiation. 6. Product can be made into easy-to-move, real-time imaging business, miniaturization, and not bound to a specific region. 7. It improves identification of tumors and other tissue characteristics. What about the advantages over an all-acoustic system? 1. The acousto-electromagnetic approach is increased sensitivity to the target interior. The large acoustic impedance mismatch between most solids and the surrounding fluid, air, in this case implies that coupling acoustic energy into the target is difficult. As a result, much of the incident acoustic energy is reflected from the target boundary and only a small amount penetrates into the interior. Two, acoustic systems have difficulty detecting shear modes because the shear waves cannot propagate into the surrounding fluid. In an acoustic electromagnetic system, detection doesn't rely on acoustic wave propagation back to the receiver. 3. In an acoustic imaging system, higher frequencies are sometimes required to achieve sufficient resolution to detect certain features of interest. In the acoustic electromagnetic approach, lower frequencies which experience much lower loss in air are adequate since the acoustic energy is used to excite resonant modes of the target rather than to image the target. 4. An electromagnetic system cannot look inside metal-coated, or very electromagnetically lossy targets because the electromagnetic wave doesn't penetrate significantly into the target interior. An acoustic electromagnetic system, however, can detect acoustic resonance frequencies and is also sensitive to the boundary perturbation which occurs at the acoustic resonances. 5. The electromagnetic signal level and bistatic patterns do not change significantly at electromagnetic resonances of the target. As a result, information embedded in these resonances cannot be used for identification. In an acoustic electromagnetic system, mechanical resonances, which also contain information about the target properties, are used as an additional target descriptor. And thank you for watching our video.